Okay, so here we are in week 4, and we've got another group of fallacies that we need to take a look at. And so the good news is there are only 6 general types in this section. There are some subtypes also within one of the fallacies, but overall just 6. So these are fallacies of weak induction. And so what's going on in all these fallacies of weak induction is that the premises of the arguments that are being made are logically relevant to the conclusions, but there's insufficient inductive evidence available. So the connection between the premises and the conclusion is not strong enough to support the conclusion, even though the premises may be relevant. So each one of these fallacies suffers from that kind of problem, and so they just happen in different ways throughout the different fallacies. So let's start with the first one here. Our first fallacy of weak induction is called appeal to unqualified authority, and this one's pretty easy to understand. What's going on here is a cited authority or witness lacks credibility. So someone is offering an argument that's based on the claims of an authority figure. And so authority-based arguments are never the best case scenario, but sometimes we have to appeal to some particular authority. For example, if we're dealing with a field of expertise that we don't have any knowledge about. If I'm trying to understand about something about black hole physics, for example, I'm not a Nobel Prize winning physicist on the physics of black holes, so I might have to appeal to some authority figure in the field like Stephen Hawking or Roger Penrose or somebody like that. So that would be an example of a qualified authority. So that type of argument wouldn't commit the fallacy of weak induction, because the authority figure is the appropriate authority figure, has expertise in that field. So what happens here is you have an authority figure that might have expertise in one area, but they're being used in an area where they actually don't have credibility. So for example, let's say I went to my physician, my doctor. I was sick, and so I made an appointment, and then while I was getting treatment from my physician, he mentions that he thinks that the most reliable cars are Toyotas or something like that. And so I tell all my friends that my doctor says that Toyotas are the most reliable cars, so everyone ought to buy a Toyota. So that'd be a good example of a fallacy of appeal to unqualified authority. My doctor may have credibility in the field of medicine, but he's not trained in engineering, mechanical engineering, where one might design cars and understand the reliability factors of cars. So authority-based arguments themselves are not fundamentally flawed. They're not the best case scenario. It's always better to have the actual evidence. But if you do construct an authority-based argument, the authority figure has to have genuine expertise in the field. Okay, second fallacy here is appeal to ignorance. So this fallacy occurs when the premises of an argument state that nothing has been proved one way or another about something, and then a conclusion makes a definite assertion about that thing. So in all appeal to ignorance fallacies, someone is essentially arguing from a lack of evidence, and you can't logically argue from lack of evidence. You can't assert, well, there's no data here either way, and then draw a conclusion. All you could do is draw the conclusion that there's no data either way about a particular issue. So let's say someone were to say, the claims of astrology have never been disproven or proven, therefore it's acceptable to accept readings of your horoscope. Right, so that'd be a good example of appeal to ignorance. Nothing's been proven either way about astrology, therefore we can accept the conclusions about astrology as being a predictable, reliable way of determining how your future is going to unfold. So now, this can be a little tricky. If there's been a systematic investigation into the issue, then the fallacy of appeal to ignorance is not committed. Let's say that someone says it's never been proven or disproven that Bigfoot doesn't exist, so therefore it's reasonable to believe that he does. In that case, there have been systematic investigations, right? People have looked for evidence for a large bipedal primate in the mountains of the northwest United States. We don't find any fossilized remains. We don't find any skeletal remains of the dead creatures and so on. So in that case, it wouldn't qualify as the fallacy of appeal to ignorance because there has been a systematic attempt to evaluate the evidence of those claims. So appeal to ignorance occurs when somebody just asserts that nothing has been discovered one way or the other, and then one draws a conclusion from that claim. Okay, so third fallacy here is hasty generalization. This fallacy affects inductive generalizations in the sense that the inductive support is weak, meaning there aren't enough instances to support the particular conclusion. So remember how induction works. You look for a pattern in reality, and then you draw a conclusion based on that pattern. And so an inductive argument is considered weak if you haven't looked for enough of the example pattern. So if you only have one observation or two observations, then the conclusion isn't strongly supported. So the more observations you have that back up your conclusion, the stronger the inductive argument is. So in a hasty generalization, you just don't have enough observational data. So let's say, here's an example of hasty generalization. Let's say I took one student randomly from the CARC campus and I gave them an IQ test their intelligence level based on the IQ test, and they scored 150, which is very high. And then I draw the conclusion from that one student that the average student in the CARC student population has an IQ of 150. The problem with that reasoning is I've only got one example. I only tested one student. So that'd be a good example of hasty generalization. Now for the argument to be cogent, for it to be a compelling inductive argument, I would need to obviously test many, many more students. I need to test up into the hundreds of number of students in order to have valid data about the average IQ of students at CARC College. So hasty generalization is pretty easy to spot. It's just not enough inductive data in support of inductive generalization. Okay, so false cause. So false cause is the overall name of the fallacy, but there are 4 subtypes. Now on the exam, I won't have you indicate the subtypes. You just have to recognize that the false cause fallacy is occurring. But it's important to understand the subtypes, because if you do, then you'll be able to spot the fallacy more easily if it pops up in real life or on the exam. So what's happening generally in false cause is it occurs whenever the link between the premises and the conclusion depends on some imagined causal connection that probably does not exist. So the most obvious example of false cause fallacy is called post hoc ergo propter hoc, which roughly translates from the Latin of this, after this, therefore this, essentially. So the idea is that this variety of the fallacy presupposes that just because one event precedes another event, the first event causes the second. So just because you have temporal succession, one thing occurs, then another thing occurs, the arguer then draws the inference that the first thing must have caused the second thing. So I ran across a good example of this this week, in fact. I have a colleague who her uncle recently died from a heart attack, and right before getting the heart attack, somewhere a few days prior to the heart attack, the man had gotten a COVID vaccination. And so now she's drawn the conclusion that she's never going to get a COVID vaccination again because the COVID vaccine caused her uncle to have a heart attack. Right. So it's possible that there was some causal connection, but she'd obviously be guilty of hasty generalization here too. She's only got one inductive example, just her uncle getting the vaccination and then dying. But it's also a false cause fallacy, right? Because since there isn't enough data to support the claim that there's a causal link between getting the vaccine and having a heart attack, then it's unwarranted to make the claim that there's a causal connection there. So if there were a systematic investigation into the effect of vaccines on heart attacks, and we could find the actual causal mechanism, we could see what's happening on a cellular level or a molecular level that would cause a heart attack, then we would have stronger inductive evidence that there's some causal connection. But just because one thing happens in time and then another thing happens later in time, it doesn't follow that they're actually causally connected. So another example, a post hoc ergo propter hoc. Let's say every time a high school football team wins, the cheerleaders wear blue ribbons in their hair. Therefore, it's the blue ribbons in the hair of the cheerleaders that cause the victory on the football field. Right? There doesn't seem to be any causal relationship between the color of ribbons that are worn by the cheerleaders and the success of the football team, but they are sequential in time. One occurs before the other, and so to draw an inference based on such an observation would be an example of false cause, post hoc ergo propter hoc. Okay, so let's look at these other subcategories of false cause. We have non causa pro causa, which translates roughly as not the cause for the cause. So this fallacy is committed when what is taken to be the cause of something is not really the cause at all, and the mistake is based on something other than mere temporal succession. So in post hoc ergo propter hoc, you have just temporal succession. One event occurs, then later in time another event occurs, and the arguer makes the case that there's a causal connection just because they follow one another in time. The events follow one another in time. In here, there's a temporal succession, but there's also something else going on. Let's say we find out that the average income for someone who subscribes to the Wall Street Journal is $200,000 a year, and then we draw the conclusion, therefore, if you want to make $200,000 a year or more, then all you need to do is subscribe to the Wall Street Journal. Well, obviously, there's a lot more going on here than just subscribing to the Wall Street Journal and then making a lot of money. In fact, the causality is probably reversed there. What's going on is that people who already have wealth and are interested in investing subscribe to the Wall Street Journal to understand financial markets better. So it's not the Wall Street Journal that's causing the wealth acquisition. It's the fact that they've already acquired wealth and then they need more information about what to do in terms of investing. So in this case, then obviously subscribing to the Wall Street Journal is not really the cause of the wealth. It's simply a secondary effect of people who have wealth wanting to invest. So that's non-causa pro causa. Then we have oversimplified cause. So this occurs when a multitude of causes is responsible for a certain effect, but the arguer selects just one of these causes and represents it as if it were the sole cause. So in reality, we all recognize that most things are caused by more than one thing. For example, if you contract cancer, it's not just because you were exposed to carcinogens in the environment. Could be if it was an extreme exposure, but usually it's a combination of other health conditions, genetic predisposition, exposure to the carcinogen, health status at that particular time, how well is your immune system functioning, and so on. So just to say that it was the carcinogen alone that caused the cancer would be implausible. So what happens in oversimplified cause is somebody focuses on one cause when in fact it's multiple causes. People say things like smoking isn't dangerous or unhealthy. It doesn't cause lung cancer. My uncle smoked until he was 105 years old and never had any lung problems. So what's going on there is that individual is not recognizing that there are other factors that determine whether or not one has health problems as a result of smoking. Like I said, it could be genetic factors, it could be the type of cigarettes, how the person inhaled. There are a lot of different instances of factors that could determine it. So, Kat's trying to get in the recording here. So, with oversimplified cause, all you're simply doing is trying to spot an example where obviously the situation is more complex and there's more than one cause involved, but the arguer is portraying it as if there's just a single cause. So then you have finally the last false cause fallacy called the gambler's fallacy. So this fallacy is committed whenever the conclusion of an argument depends on a supposition that independent events in a game of chance are causally related. So think of the casino. People at the casino playing slot machines. Say you're standing there and someone's playing the same slot machine for an hour and a half, pulling the arm over and over again, and this person doesn't hit the jackpot. They don't win any money. And then as soon as they get up and leave, somebody runs over and jumps in the chair. They want to be in that machine because they consider the slot machine hot, meaning that it has a higher probability of returning a jackpot because the person previously didn't win for a certain period of time, so they argue or believe that it's more likely that they'll win because the other person sort of used up the losing pulls prior to them getting in the seat. So this is not how slot machines work, obviously. Each time you pull the arm on a slot machine, the probability of a jackpot is the same. If the machine is designed fairly and correctly, of course, they could rig it to where it's not the same each time. But by law, the machines are required to have meet certain standards, and one of those standards is that each time in a game of chance, the outcome has to be the same. For example, you pull the arm, it has to be the same each time. So believing that there's such a thing as a hot slot machine that increases the probability of a win if somebody else had used it prior to you using it, that'd be a good example of the gambler's fallacy. Okay, so let's move to our next one. That's leaving false cause then. So those are the four subtypes. And finally, we have a slippery slope here. So this is a variety of false cause fallacy. It occurs when the conclusion of an argument rests on an alleged chain reaction for which there is insufficient reason to think the chain reaction will actually take place. So technically this is a kind of false cause fallacy, but it's generally viewed as a distinct fallacy from the false cause category. It does involve illicit causal relations that don't really make any sense, but it has sort of its own independent and obvious structure. So what happens in slippery slope is somebody makes a claim that, you know, if we accept A, then we have to accept B, and if we accept B, then we have to accept C, and if we accept C, then we have to accept D. And this can go on for a lot of steps, and then eventually you end up with a conclusion at the end that's just implausible because there have been so many steps that have led us down the wrong path. Now, slippery slope is pretty easy to spot because the slippery slope arguments will always have multiple steps. So anytime somebody gives you an argument that has multiple steps, you start thinking immediately, this could be slippery slope. So now, not all stepped arguments commit the fallacy of slippery slope, but if you end up in a pretty unusual place with your conclusion in comparison to the first step in the argument, then probably the fallacy of slippery slope is being committed. So a good example would be, for years they wouldn't allow casinos in Arkansas. So the arguments were almost always clear examples of slippery slope arguments that were offered against the acceptance of gambling in Arkansas. Critics of casinos would say things like, look, if we allow casinos in Arkansas, then we're going to have increased crime because gambling increases the probability of a criminal element. So you're going to have more illicit drug sales as a result of that. And if you have more illicit drugs, then you're going to have more prostitution. And if you have more prostitution, then you're going to have more murders. And so the idea is that if we allow casinos, then there are going to be all these little steps that lead to basically the decay of society. And nobody wants the decay of society, therefore we shouldn't allow casinos. And we know that these are all false claims because you can construct casinos in a way where you make it unlikely that all these other criminal things would occur. And so you could, in fact, pay for your pay to make your police force more robust and have a higher police presence around the casinos because you'd have higher tax revenue from taxing the casino itself. And so there are lots of ways that you could get around that sort of slippery slope argument. So slippery slope, like I said, is pretty easy to spot. You're going to see multiple steps starting from a very innocent claim to some a kind of crazy, disastrous claim. Okay, so then our final fallacy in this grouping, fallacies of weak induction, is weak analogy. So this fallacy, which affects inductive arguments from analogy, is committed when the analogy is not strong enough to support the conclusion. So an analogy is a comparison. So an analogical argument or an argument from analogy is an argument based on a comparison. And comparison arguments are very compelling arguments if they're constructed correctly. So analogical arguments in and of themselves are not fallacious, they're not bad logically. But if they're constructed based on a poor comparison, then they are logically flawed. So if let's say I'm comparing automobiles and I compare the horsepower of my car. Say my car has an engine that produces 300 horsepower, and then this other person's car has an engine that produces 300 horsepower, and then I say, well, my car can go 100 miles per hour, therefore it's likely that this other individual's car can go 100 miles per hour. That's probably a strong analogical argument because we're comparing the right kinds of things that determine how fast a car can go. The horsepower that's produced by the engine. Now, on the other hand, let's say I said, well, my car is blue and it has black interior and it has a steering wheel and it gets 30 miles to the gallon. And so this other person's car is blue, painted blue, it has black interior and also has a steering wheel, therefore it likely gets 30 miles to the gallon. So that would be an example of a weak analogy because the things that we're comparing there are not relevant to fuel performance. The color of the car, the color of the interior, having a steering wheel don't determine the miles per gallon that a car will get. Factors that determine fuel economy on a car are things like the number of cylinders that the car has in the engine, whether it's electronic fuel injection, whether it has a certain curb weight, how much it weighs, aerodynamic styling, how is the body shaped and how much drag does it have. So if we're just comparing the color of the car, the interior upholstery color and so on, and having a steering wheel, then we're not comparing the right sort of factors, and we'd be committing the fallacy of weak analogy. Okay, so those are our fallacies of weak induction. So just like the first grouping, you'll have a couple practice quizzes where I'll have examples of fallacies of weak induction, and then a graded quiz that is structured in the same way but with just different questions. Good luck, and I'll see you next week. We have one more grouping of informal fallacies, and then we'll be finished with the fallacy stuff and moving on to categorical propositions and syllogistic logic. But we're getting closer to the end. We're at the halfway point. This is week 4, and so I hope everybody is happy with the class and doing well, and see you guys next week.